Okay, so now welcome back. So these are the properties that you need to remember, no? So for example, reflexive property, we will use it to state that something is equal to itself. The transitive property, so if I have AB equal to BC and BC equal to EF, then I can conclude that AB is equal to EF. So for example, I don't know, imagine that I am uh, related to someone, related by blood, like your family, and this person is also related to someone, so that makes us related in between each other, no? So it is like if A is equal to B and B is equal to C, then A is equal to C. No, like a transitive property because it transits, like it moves along the individuals. Symmetric property, so if A is equal to B, B is equal to A. Addition, wherever you're adding. Subtraction, whenever you're subtracting. Multiplication, whenever you're multiplying. Dividing, whenever you're dividing. A substitution, whenever you're plugging in. This one, we're not using it, no, but it's always for constructions. Like when you have a segment, okay, and now I have a segment AB, and now I can put a point in the middle, and so AC is the same as AC plus CB is the same as AB. We will not use it a lot, now the partition property. But whenever you're adding, it's addition property, subtracting, subtraction, multiplication, multiplying. These ones are the ones that have a hard name. Okay, so here we want to write a proof for the exterior angle of a triangle. So for example, here we can label this angle, we can label angle W, and now say that angle W is the same. So W, or we can say like W is the same as 180 minus X minus Y. No, and the reason is angles inside a triangle at 180. Then we can say like C equals to 180 minus W. No, because a linear pair of angles are supplementary. Then we can use, so we can set this equal to this. So I am sorry, did I wrote it? I wanted to write this. I wanted to write W. Then we have the W is equal to W, and that is called the reflexive property. Then we can set 180 minus X minus Y equals to 180 minus C. That is called the substitution property. Then we can subtract 180 in both sides. So we will get minus X minus Y equals to minus C. That is the, it's interesting because now how do I, okay, so now that is a subtraction property. And now that means that X plus Y equals to C because I multiply everything by -1, and that is a multiplication property. And here is the argument that I wanted to prove. Okay, so this one, if you remember, we proved it in the last lesson. I am just now writing it in a two-column table. So first, make an informal plan and then write it down. So solving these exercises will be easier if you first have a plan. Okay, here, what do we want to prove? We want to prove that W plus X plus C equals to 180. It is very clear that it is true. Why? Because this is the same as this. And we already know that X plus Y and C Okay, we know that x plus y plus c equals to 180 because of the triangle addition. And then we know that w is the same as y because they are vertically opposite. So from here and here, we use the substitution property to get the equality that we wanted. Okay, let us write it down. So my statement and my reason. So we know that W, angle W is congruent to angle Y because they are vertically opposite. Then we know that angle X plus angle Y plus angle C equals to 180 because angles in a triangle add up to 180. Then we can just substitute, no? So we know that the measurement of angle X plus the measurement of angle W plus the measurement of angle C equals to 180 by the substitution property. And that is what we wanted to prove. Okay. So here we want to prove that angle W is the same as angle Y plus angle C. So like in little alchemy, no, we already know that angle, okay, in little alchemy, because in exercise 1, in this exercise, we proved that C is equal to X plus Y. So we already know that exterior angles triangle equals the sum of interior angles. So we already know that. So we already know that angle W, the measurement of angle W, is the same as the measurement of angle X plus the measurement of angle C. This is the lava of little alchemy, no? We can already use it as a reason. Everything that we state, that we prove, is also a thing that we can use to prove new things. We don't need to rewrite this proof again. Now we can just invoke it. And then, well, we can see very clearly that the measurement of angle X is the same as the measurement of angle Y because they are vertically opposite. And then we can use substitution property. Okay, so my statement and my reason. So my first statement is that angle W is the same as angle X plus angle C. And this is my reason, no? Exterior angles in a triangle equal the sum of the interior angles. Then we can see that angle W is the same as angle X because they are vertically opposite. And then we know that, sorry, not angle X, it's angle Y. Then we can write just angle W equals to angle Y plus angle C because of the substitution property. Okay, so this is going to become harder and harder. Now, this is very cool. They are asking us to prove that the sum of these two angles is equals to the sum of these two angles. Okay, so when I was in class, one student said to me, Mr. Gachoa, are the lines parallel? Is the triangle an isosceles triangle? And I am like, no and no. So how do we do this? So you know that I'm just going to write CYA without the measurements. C plus Y plus A equals to 180. Uh, so we know that C plus, from here, we know that C plus Y equals to 180 minus 8, because you're looking at this triangle. And then if now you look at this triangle, you will see that x plus w plus a equals to 180. So x plus w equals to 180 minus a. So because this is the same as this, 180 minus a equals to 180 minus a. That is a reflexive property. And then x plus w equals to c plus y. Because of the substitution property. Okay, now let us write it. 2 columns, statement, and reason. So my first statement is a plus x plus y equals to 180. Reason: angles inside a triangle at 180. Then x plus w plus a. No. No. Ay. A plus c plus y equals to 180. Then a plus x plus w equals to 180, and it's the exact same reason. Then c plus y equals to 180 minus a because of the subtraction property. Then x plus w equals to 180 minus a due to the subtraction property. Then 180 minus a equals to 180 minus a due to the reflexive property. So c plus y equals to x plus w due to the substitution property. And that is what we wanted to prove. Okay, very good. Now this is a super cool one because it has a lot of c's. So this is parallel to this, and this is parallel to this. So here you have a lot of c's. So we want to show that angle ABC is the same as angle CDE. And that is true, because look, so EDC is the same as DCV because alternate interior angles. And then DCV is the same as CVA because alternate interior angles. And so if this is equal to this, and this is equal to this, then this is equal to this due to the transitive property. Okay, let us write it down. Let us write it down. So my statement and my reason. So angle EDC is congruent to angle DCV. Because they are alternate interior angles. Then angle DCV is congruent to angle CVA. Because alternate interior angles. Then angle EDC is congruent to angle CVA because the transitive property. And that is all. Super cool, don't you think? Super cool. Okay, so this one, I don't want to write it. I don't want to write it. Okay, I will write it. I will write it. Okay, so okay, this one. So we can do it. The problem is that we need to label things. We need to label several things. So I'm gonna write it. I'm gonna write it. Okay. A, B, C, D. I no 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 no. A, B, C, D, E, F, G, H, I. And I'm gonna call the points X, Y, C. Okay. So the angle marked by the arrows, for example, this angle is angle FA, FXA plus AXB plus BXC. Do you agree? Because FXA plus AXB plus BXC. Then this angle here is angle CYD plus DYE plus EYF. And this last one is angle FCG plus GCH plus HCI. Okay, now, do you agree that this angle, this sets of angles, plus this one is 360? And this set of angles plus this one is 360. And this set of angles plus this one is 360. So each circle is 360, and we have a triangle. The triangle that measures 180. So for this problem, we do 360 plus 360 plus 360 minus the interior angle, that is 180. Minus the interior angle, that is 180, and that will give you 900. Okay, so let us write it down. It is going to be, this one is tough. Okay, so I'm going to write it in each color, no? O sea, a ver, statement and reason. So the measurement of angle CYD plus the measurement of angle DYE plus the measurement of angle EYF plus CYF is 360, because angles around the point is 360. Okay, then the measurement of angle FCG plus the measurement of angle GCH plus the measurement of angle HCI plus the measurement of angle FCI equals to 360. Again, because angles around the point, 360. Then the measurement of angle FXA plus the measurement of angle AXB plus the measurement of angle BXC plus the measurement of angle CXF that equals to 360 because angles around the point are 360. Then angles CYF, this one plus this one plus this one, plus angle FCI plus angle CXF equals to 180. And that is angles in a triangle. To 180. Then, if we add all of these angles, that will give us the sum of 360 times 3. And then we subtract those 3 angles, no? So I'm going to write it, and it's going to be awful. Sorry. Okay, but I'm going to write it in a very cool way because technology allows me to. So look what I'm going to do. So this plus this plus this equals to 360 times 3. What is 360 times 3? That is 1080, and that is the addition property. No, I added the 3 things, and that gives me 180. And then I subtract these ones, no? I can even organize them a little bit better. I think that this is easier for me than rewriting them. To 900, no? And this is the subtraction property. And that is what you wanted. Oof! Writing this was horrible, but it was interesting. I believe that if you got this idea, then you got everything. Don't worry. This was a very tough, a very tough proof to write. Okay. Now, let's go for the next one. So DC and EF are perpendicular. So that means that DC and EF, they have a 90-degree angle here. No. Perdón, sorry. We want to prove that these two are perpendicular. So we want to find this angle and prove that that is a 90-degree angle. So for example, so before, let's do our plan. So if you look at this triangle, that is clearly an equilateral triangle because this is 60. Now, if you look at this triangle, it's gonna, this angle is gonna be 30, no? Because you have 90 plus 60, that is 30. And then if you look at this triangle, then this is gonna be 90. And that will show that that those lines are perpendicular. Okay, so how do you do it? So statement. So angle AEF is 60, angle EAF is 60, and that is given, like earth, like fire, like water, that is given. Then we can calculate angle AFE, and that is 60, because angles in a triangle add to 180. Then angle DCB is 60, and angle CBD is sorry. BDC, BDC is 90. And this is given. And this is, well, given, no? Yeah, because they're giving you this square. Then angle CDF sorry. Yeah, CDF is 30 because angles in a triangle 180. So this is 30. And I'm going to label this point as Q. Then angle DQF is 90 degrees because angles in a triangle add to 180. I am talking about this triangle. Then I know that line EF is perpendicular to line CD, and that is the definition of perpendicularity. That is what we wanted to prove. Now DC perpendicular to EF. Awesome. Awesome. Okay. Now here we want to prove that two lines are parallel. So we're going to use the converse of the alternate interior angles. So observe that if this angle measures 138, then this angle measures 42, because this and this are linear angles. And then this one and this one are the same. That means that they are corresponding angles that are congruent, so they are parallel lines. If corresponding angles are congruent, then the lines are parallel. So we just need to label these points. I'm going to label this A, B, C, D, E. We can use D for here. E, A, B, C, D, E, F, and here G. Okay, so observe. So angle ADB is 138. And that is given. Then angle BDC equals to 42 because those are linear pairs. Then angle F, A, B, C, D, E, F, G, H. Angle AFHD is 42, and that is given. So we have that angle BDC is the same as angle FHD. Well, I can write 42 equals to 42, so reflexive property. And then I can write this by doing substitution property. And now we can state that line M is parallel to line M because if corresponding angles are congruent, then lines are parallel. So whenever you want to prove that a couple of lines are parallel, you can show that corresponding angles are congruent, or you can also show that alternate interior angles are congruent, or you can also show that same side interior angles are congruent. Okay. Now this one, I'm going to skip it. I am sorry. It is because I am actually not going to ask you something like this ever, no? Because the problem in here is just to label things. And I don't care about labeling right now. What I do care is that you do know how to ensemble an argument. So for example, this is a crazy one because if you are able to create an argument like this, I don't care that you can write it like this. No, this is an argument that I do care. This is an argument that I do want you to write, but this one I don't. No, this one you need to, again, to label A, B, C, D, D, da, 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 da. Okay, so for example, if you want the hand waving argument on why this is true, so you know that let us give a hand waving argument, no, like not a proof. So this angle is an exterior angle. So you know that this, okay, if I call them X, Y, C, you know that this is X plus Y. You know that this is Y plus C. And you know that this is X plus C. So adding these three angles, you would have X plus C plus X plus Y plus C. So now if you collect like terms, you have 2X plus 2Y plus 2C. And that is the same as 2 times X plus Y plus C. And that is the same as 2 times 180. No, because X plus Y plus C are angles inside of a triangle. And that is 360. So that is like an argument. You can write it in a two-statement column. Maybe we can write them without labeling the points, just labeling these angles. But no, because you need to label the exterior angle, no? So I'm